Bill, a figure widely recognized for his deep understanding of technology, has captivated audiences for years with his unique ability to explore both the latest scientific advancements and the lingering questions surrounding vintage tech. With a passion that bridges past and future, he has become a guide for those intrigued by the mysteries of the universe and the tools we use to uncover them. Bill N9 has taken this passion even further by steering our curiosity into the vast, unexplored reaches of space. Through his observations and insights, he helps unravel the secrets that lie far beyond Earth's atmosphere in the infinite expanse stretching out into the cosmos. Recently, Bill has turned his attention to something truly historic: the latest images captured by the James Webb Space Telescope. These remarkable photographs don't just show distant galaxies. They offer a portal into the universe as it was more than 13 billion years ago. For the first time, we can peer into the ancient past of space itself. This isn't just about astronomy, it's about changing how we see everything: the origins of stars, the formation of planets, and perhaps even the place of life in the grand design of the universe. The James Webb Space Telescope, often referred to simply as Webb, is now delivering discoveries on a scale once thought impossible. It's allowing scientists to investigate the structure and evolution of planets, distant galaxies, and a wide variety of cosmic phenomena. This telescope is more than just a successor to Hubble. It's a leap forward, a revolutionary tool that is fundamentally transforming how we understand the universe. What makes Webb's photographs so impactful is their sheer detail and clarity. These aren't just prettier images. They're pushing the boundaries of scientific knowledge and challenging many of our long-standing theories about space and time. As Bill explains, the development of this extraordinary telescope was a long and complex journey. It required years of tireless work from engineers, astrophysicists, and researchers across the globe. After its launch on Christmas Day in 2021, Webb underwent a precise and flawless deployment process. Over the months that followed, its systems came online step by step until it was fully operational. By the end of June 2022, the scientific community was already seeing the fruits of this work. Thousands of new galaxies were being identified, many farther away and older than any discovered before. Some of these ancient galaxies may have formed as early as 150 million years prior to the oldest galaxies detected by the Hubble Space Telescope. This alone represents a dramatic leap in our cosmic timeline, pushing back the boundaries of what we thought we knew. The telescope's ability to capture faint light from distant celestial objects also means it can reveal intricate details about their composition and behavior. Bill points out that these early discoveries have opened the door to examining the atmospheres of planets orbiting other stars. Planets located many light years away from us. Webb is already beginning to provide precise data about these distant worlds, helping scientists determine their atmospheric makeup and assess whether they might harbor conditions that could support life. One of the most iconic images ever taken by the Hubble Space Telescope is the Pillars of Creation in the Eagle Nebula. These towering clouds of gas and dust have fascinated both astronomers and the public alike. But while Hubble captured the visible light emitted by the region, it wasn't able to penetrate the dense material within the pillars to show what was happening inside. With its infrared capabilities, Webb has now taken this observation to the next level. The telescope has revealed clusters of forming stars, known as protostars, within the pillars. These appear as small red dots scattered across the towering structures. According to Bill, these stars are still in the very early stages of their development. At this point, they're not yet burning hydrogen. Instead, they're slowly accumulating mass as gravity pulls more and more material into their cores. As they grow denser, their core temperatures begin to rise. Eventually, They reach around 2 million degrees Celsius, at which point nuclear fusion ignites and a true star is born. The colors in these images are not arbitrary. They represent different wavelengths of infrared light, radiation that our eyes cannot see. The blue areas in the image represent the visible spectrum, while red highlights the longer, infrared wavelengths. Protostars emit energy at wavelengths about 6 times longer than the range of human vision, which is why the Webb's infrared instruments are so vital. This allows astronomers to witness, for the first time, the hidden birthplaces of stars within dense clouds of dust and gas. Bill notes that this doesn't just showcase the power of the Webb telescope. It fundamentally changes our understanding of how stars like our own sun come into existence. The discovery of planets orbiting other stars, or exoplanets, began in the 1990s. Since then, astronomers have confirmed the existence of over 5,000 exoplanets. Yet only a small number of these planets have ever been directly imaged. Most are so distant and dim that we can only detect them indirectly, often when they pass in front of their host stars and cause a slight dip in brightness. But that changed in September of the previous year. Webb captured the first direct image of an exoplanet. The planet in question, HIP 65426b, was originally identified in 2017. Webb's advanced coronagraphs, devices that block the overwhelming glare of a nearby star, enabled it to isolate the planet's light. This planet is a gas giant, roughly 12 times the size of Jupiter, and it orbits its star at a distance about 100 times farther than Earth is from the Sun. In addition to its exceptional imaging capabilities, Webb's sensitivity to infrared light makes it possible to study galaxies in extraordinary detail. Take the Ghost Galaxy, officially known as M74. To the naked eye, it's barely visible. But Webb's infrared instruments reveal a rich tapestry of warm dust and gas, with intricate tendrils extending from a luminous central core that glows with a bluish hue. Star-forming regions are spread throughout the galaxy's graceful spiral arms. By merging data from both Webb and Hubble, scientists have created dazzling composite images that bring together both optical and infrared observations. These composites offer a more complete view of galaxies like M74. As part of the FANGS project, a collaborative research effort led by the European Space Agency, data from Webb, Hubble, and ground-based observatories have been used to study 19 nearby galaxies in detail. Webb's longer infrared wavelengths allow astronomers to identify where stars are forming, accurately measure the masses and ages of star clusters, and analyze the composition of dust particles scattered across the cosmos. Another fascinating example comes from an image of a distant star known as WR140. Captured in July of last year, the photo initially appeared to include the standard diffraction pattern seen in many telescope images, but surrounding this bright star was something unusual: a series of concentric rings. These aren't artifacts. They're a characteristic feature of Wolf-Rayet stars, massive stars that are nearing the end of their lives and have shed much of their hydrogen. The ring shapes are the result of interactions between WR140 and a smaller companion star, which together create these rippling patterns in the surrounding gas and dust. Webb's most groundbreaking discoveries are likely still ahead. One of its core missions is to observe the earliest galaxies ever formed, and in December of last year, scientists confirmed the discovery of 4 galaxies dating back 13.4 billion years, when the universe was only about 350 million years old. That's just 2% of the universe's current age. These 4 ancient galaxies are among the oldest ever observed, providing an extraordinary glimpse into the conditions that existed shortly after the Big Bang. Like many of Webb's discoveries, these galaxies were identified as part of a dedicated research effort. The JADES, James Webb Advanced Deep Extragalactic Survey project. By using Webb's near-infrared spectrograph, researchers were able to measure how much the light from these galaxies had been stretched due to the expansion of the universe, a phenomenon known as redshift. The highest redshift recorded so far is 13.2. According to Bill, these galaxies are older and more developed than scientists had expected, offering a tantalizing view into the era when the first galaxies were just beginning to take shape. In another impressive feat, Webb has also focused on the atmosphere of a distant exoplanet called WASP 39b, which orbits a star in the Virgo constellation. This planet is located about 700 light-years away and circles its host star at an incredibly close distance, 8 times closer than Mercury is to our Sun. WASP 39b is a gas giant roughly the size of Saturn, and due to its proximity to the star, it experiences extremely high temperatures. Webb's observations revealed a complex atmosphere containing sulfur compounds and silicate clouds. Scientists even detected the presence of sulfur dioxide. Using 2 of its spectrographs, Webb also identified carbon dioxide in the planet's atmosphere, marking a huge step forward in the field of exoplanet studies. Each of these discoveries builds upon our growing understanding of the universe. With its unmatched precision and range, the James Webb Space Telescope is not only changing the way we see space, it's transforming our very idea of what is possible. And thanks to the continued insight of observers like Bill, we're able to appreciate both the science and the wonder that comes with each new image and revelation.